In the future, Starship will journey even further, undertaking a range of critical space missions. The driving force behind these ventures is undoubtedly the Raptor engine. After focusing on landing capabilities in recent flights, the time is approaching to demonstrate the Raptor's potential for in-space operations. Preparations for this next phase are well underway. So how is SpaceX progressing with Raptor's readiness for space? Will we see the Raptor engine operating beyond Earth's atmosphere soon? And how will this milestone impact the path ahead? According to recent reports, the U.S. Department of Defense is set to significantly increase its budget for a low Earth orbit satellite internet system, raising funds for the Proliferated Low Earth Orbit satellite-based services program from $900 million to an anticipated $13 billion. This notable investment aims to support the connectivity needs of all U.S. military branches, with a focus on high-speed internet satellite systems that enhance military operations. Specifically SpaceX's Starlink satellite network. Every branch of the military, infantry, navy, and air force requires reliable satellite systems for communication, positioning, tracking, observation, and more to ensure mission effectiveness. The PLEO program operates under an Indefinite Delivery Indefinite Quantity, or IDIQ, contract, managed by the Defense Information Systems Agency, or DISA, as well as the Space Systems Command's Commercial Satellite Communications Office. This IDIQ structure allows the military to engage multiple vendors, fostering competition, and comes with a 5-year contract term with a possible 5-year extension. Leveraging commercial satellite technology ensures the military benefits from the latest technological advances. While many vendors are participating in the PLEO program, SpaceX has already emerged as a key player, securing $660 million under the initial $900 million allocation for Starshield, the military-specific version of Starlink. SpaceX's satellite system has proven itself in numerous scenarios, providing high-speed, low-latency internet in areas unreachable by traditional networks, aiding communities during natural disasters, such as the recent earthquakes in Japan and Hurricanes Helene and Milton, and supporting Ukraine's defense infrastructure against external threats. Additionally, Starlink has demonstrated its space applications through projects like the Polaris Dawn mission and Starship flights. One of the key advantages of Starlink is its ease of installation. There's no need for cumbersome wiring or intermediate stations. All that is required is a terminal device that can be set up anywhere with a clear view of the sky, ensuring a reliable internet connection. The strength of the Starlink system lies in its operational altitude, which is significantly lower than that of competing systems. This unique positioning facilitates increased access speeds and reduced latency. Furthermore, the sheer quantity of satellites contributes to its power. SpaceX has launched over 7,000 satellites to date, with more than 6,000 currently in operation. Recently, SpaceX celebrated a milestone announcing Falcon 9 launches our 200th Starlink mission to orbit, to which Elon Musk responded, "Congrats, SpaceX team, on the 200th successful Starlink flight." Building on this momentum, SpaceX is preparing to develop Starshield, a military-focused satellite system that may be launched aboard the Starship. Once operational, Starshield's capabilities are expected to significantly enhance communication efficiency, data analysis, and rapid transmission of critical information. Additionally, in remote areas where traditional network systems fall short, Starshield will ensure reliable communication and connectivity. More importantly, Starshield's extensive operational range will serve as a valuable tool for detecting external threats, providing timely warnings to the defense system, and enhancing overall national security. These capabilities are crucial for the success of military missions, and with Starshield, the United States aims to reinforce its position as the most powerful and advanced military force in the world. Turning back to the PLEO contract, various satellite systems have been proposed, including Amazon's Kuiper system. However, in terms of capabilities and timelines, Kuiper does not measure up to SpaceX's offering. Given the demonstrated advantages of SpaceX's systems, I am confident that the majority, if not all, of the $13 billion will be allocated to SpaceX's initiatives. What are your thoughts on the contract awarded to SpaceX? Are there any alternative systems you believe could compete effectively against them? Share your thoughts in the comments section down below, and don't forget to like, share, and subscribe to our channel to stay updated on SpaceX's journey and advancements. Now, to deploy Starshield, we must consider the critical role of Starship. Choosing Starship for this mission is undoubtedly the right move, given the constraints on Falcon rockets now and in the future. But even more compelling is Starship's immense potential. With a current payload capacity of approximately 100 tons and the possibility of exceeding 200 in the future, Starship can carry 4 to 10 times more mass to low Earth orbit than Falcon 9 and 1.5 to 3 times more than the Falcon Heavy. This means each Starship launch could deploy over 100 satellites compared to the current limit of 23, significantly accelerating satellite system deployment to meet the military's urgent needs. Another advantage is Starship's potential for full reusability, which would drastically reduce costs. This competitive price point strengthens Starship's appeal for both SpaceX and the Pentagon. Both SpaceX and the Department of Defense can be confident in Starship's development progress. In just 1.5 years, SpaceX has achieved milestones like catching Super Heavy with the chopsticks and performing controlled vertical landings with Starship. In the coming year, SpaceX aims to recover the entire Starship system by attempting a chopstick-assisted ship landing, targeting full reusability by early 2025. Once this goal is achieved, SpaceX's focus will shift to payload launches, initially likely for Starlink satellites, as we've seen with Falcon missions. When stability in these missions is reached, Starshield launches will likely follow. Based on current progress, we could see Starshield launches as early as third quarter or fourth quarter next year. Comparatively, Amazon's Kuiper system, although promising, faces challenges due to reliance on slow-developing rockets. Blue Origin's New Glenn, ULA's Vulcan, and ESA's Ariane 6. This choice has led to delays that underscore the advantages of SpaceX's more agile approach with Starship. New Glenn has yet to complete its first mission despite extensive preparation. At best, it might manage a single launch this year. To qualify for national security missions, New Glenn will need a successful second mission, projected no earlier than early next year. Even then, there's no certainty that everything will proceed smoothly or that New Glenn will be ready to handle Kuiper launches soon after. Vulcan, initially expected to perform strongly, has also faced delays. Despite completing its second mission in October, it now faces a backlog of National Security Space Launch Program missions. These delays and operational uncertainties make its ability to support Kuiper launches unpredictable, with existing issues adding further risk to each mission. As for Ariane 6, its debut mission in July, after years of delay, revealed issues that cast doubt over its upcoming schedule. These setbacks have cost Ariane 6 numerous launch contracts to SpaceX, leaving the Kuiper timeline even more uncertain. Given these challenges, the military is unlikely to rely on a system with such consistent delays. This scenario highlights why SpaceX's satellite internet and launch capabilities have become the preferred solution across many sectors, especially for the military. Even now, with only the Falcon and Starlink systems, SpaceX has surpassed competing satellite constellations and launch services. Once Starship and Starshield are fully operational, the potential becomes even greater. A powerful, user-friendly, reliable, and flexible satellite network paired with a launch system capable of heavy payloads, full reusability, and rapid development, an ideal combination to meet any launch schedule. Considering this, allocating the full $13 billion to SpaceX seems a logical choice for the Pentagon. This is how SpaceX and its systems will once again demonstrate their superiority. Over the past year, Starlink has demonstrated its capabilities across various sectors, solidifying its position as a leader in satellite communication. Its application within the aerospace industry has been particularly notable, showcasing how reliable connectivity can enhance operational effectiveness. As we move forward, there is a pressing need for Starlink to take a significant step in bolstering national security. This objective aligns seamlessly with the mission of Starshield, SpaceX's military-grade satellite system designed to provide secure, high-speed internet for defense operations. Central to this initiative is Starship, SpaceX's ambitious and massive rocket currently undergoing rapid development. Starship's potential extends beyond its intended lunar and Martian missions. It is increasingly recognized for its critical role in launching internet satellites, specifically tailored for military use. This versatility not only enhances the capabilities of Starlink, but also ensures that the U.S. military can maintain a competitive edge in global communications. When will the Starship human landing system be ready? This is the burning question for aerospace fans since SpaceX was selected for the Artemis 3 mission. Surprisingly, the answer may have been right in front of us all along at the Starbase production site. Though most of us, myself included, hadn't focused on it until now, recent updates have revealed exciting details about the interior design within this specially modified nose cone. These designs give us a glimpse into how astronauts will live on their journey to the moon. So, just how remarkable are these designs, and what comes next? With Artemis 3 less than 2 years away, the world is eagerly anticipating humanity's return to the moon. Alongside Starship's development, the unveiling of Starship HLS is highly awaited. This nose cone, featuring a unique design, has been stationed at the production site for quite some time. Although work on it hasn't been conducted behind the scenes, which has led to waning attention, recent leaks on X have reignited interest. Intriguingly, sources have provided a glimpse into the crew accommodations within the Starship HLS nose cone. And right as I was preparing this video, the space engineer team released a 3D model of the interior layout, bringing my descriptions to life. Huge thanks to the space engineer team for crafting such a detailed visual. Make sure to follow them on X and subscribe to their YouTube channel to support their work on future projects. Now, let's break down the design. According to the images and leaks from other contributors, including Tom Bickmore, who shared that he had been inside the nose cone, the crew quarters are divided into 2 primary decks. The upper deck will serve as the main workspace and private quarters. Current plans show 5 bedrooms for astronauts, arranged with a layout inspired by the ISS, but with a horizontal orientation to offer a more familiar living and working environment. With a clever domino layout, SpaceX can even expand each ship ring to accommodate up to 20 bedrooms, showcasing the Starship HLS's impressive capacity for a large astronaut crew. Adjacent to the crew bedrooms is the central control room, which will feature 4 seats similar to those in the Crew Dragon, complete with a touch screen to oversee and control the entire system. Besides the standard control screens, large wall displays will serve as virtual windows, promising astronauts an unparalleled visual experience. On this same upper deck, other essential subsystems are housed, including the life support outlet, storage rack, shoe cover storage, and system switchboard. There's also an emergency exit for added safety. The lower deck is slightly smaller and will primarily serve as storage for life support equipment, specifically the Environmental Control and Life Support System, or ECLSS, and will include critical components like the heat exchange system. This area is also likely to store research gear, lunar rovers, and supplies such as food and water. Although not yet confirmed, it's expected that the lower deck will also house the restroom facilities. The deck's flooring has a curved design shaped by the pressure vessel dome, but it will be optimized to ensure smooth movement for the crew. Connecting the 2 decks is a functional 15-step staircase, offering astronauts seamless movement between levels within the Starship's interior. The upper deck boasts an awe-inspiring 40-foot ceiling, giving astronauts an open, spacious area to adjust to the moon's lower gravity before stepping onto the surface. This expansive space is not only visually captivating, but also serves as a training environment where astronauts can familiarize themselves with the unique conditions they'll face on the lunar landscape. While this 3D model provides an exciting glimpse into the design, it doesn't capture every operational detail. Fortunately, recent updates offer insights into the airlock corridor, a crucial component equipped with integrated control panels to manage essential systems. These panels ensure everything is set for lunar operations before astronauts exit the spacecraft. The main hatch in this corridor is expected to connect with a specially designed elevator system, which SpaceX has rigorously tested. This elevator will safely transport astronauts from the crew area, positioned a remarkable 50 meters above ground, down to the lunar surface, simplifying their descent. These recent updates are just the beginning, with more impressive details likely to emerge as the Artemis 3 launch approaches. Starbase has become the focal point of a quiet revolution in space exploration, unveiling advancements that continuously push the boundaries of what's possible. Every new revelation offers us a deeper look into SpaceX's commitment to making lunar missions more accessible and efficient. If you could describe these developments in one word, what would it be? Let me know your thoughts in the comments section down below, and as always, like, share, and subscribe to stay updated on SpaceX's incredible journey into the next era of space exploration. Beyond the intricate nose cone section, undoubtedly the most complex and mission-critical part of the Starship HLS, SpaceX is making significant headway on the rest of the vehicle, which includes the fuel tanks and engines. These essential components will span about 30 to 35 meters of the spacecraft. Like the nose cone, HLS's exterior materials will diverge from the standard Starship design, as it will not feature flaps or heat shields due to its lack of atmospheric re-entry. Currently, 2 design concepts for Starship HLS are under development. One concept features foldable landing legs, an enlarged crew compartment, and aft-mounted solar panels that will deploy in a propeller-like configuration. The second concept opts for fixed landing legs and body-mounted solar panels that will extend in multiple directions, alongside adjusted thrusters. While none of this specialized hardware has appeared at Starbase, it's likely that some of these components are being assembled at a separate, more confidential facility, much like the nose cone. The final iteration of Starship HLS will probably follow the V2 model design that's presently under production. This continuity could mean a preliminary launch to test systems, particularly the fuel transfer mechanism, which is essential since Starship HLS will require mid-mission refueling to reach the moon. So when will it all come together? SpaceX still has 2 V1 vehicles in the pipeline, though only one more V1 flight, likely with S31 and B13, is expected before year-end. Following this, V2 is anticipated to take flight early next year. This suggests that the first Starship HLS could make its debut around mid-next year. A crucial milestone will be the complete assembly of Starship HLS hardware. Once all the components are in place, assembly should be swift. V2, for instance, took only about 6 weeks. Following assembly, SpaceX plans to move forward with an uncrewed test flight, currently slated for late 2025 or early 2026. In parallel with vehicle development, SpaceX is pushing forward with essential infrastructure projects. They are expected to expedite the launch pad build in Florida, where NASA will manage Starship HLS's launch. Another priority is the orbital refueling infrastructure, with potential test operations beginning by March next year. If these systems are successfully tested, they will be ready for uncrewed test flights and subsequent operational missions, establishing a robust foundation for lunar missions and beyond. These advancements signal SpaceX's focused commitment to turning Starship HLS from concept to reality. As they approach crucial milestones, each successful step brings humanity closer to an extraordinary era of space exploration. SpaceX's recent achievements and strategic plans provide a reassuring perspective on the timeline for Artemis 3, alleviating previous concerns about potential delays. Just months ago, skepticism surrounded Starship's readiness for the mission, particularly since Super Heavy had yet to complete a controlled landing and Starship itself had not undergone re-entry testing. However, SpaceX has made remarkable strides in a short period. Super Heavy successfully achieved a controlled ocean landing and followed that with a successful landing utilizing the Megazilla arm. Meanwhile, Starship accomplished a controlled vertical landing on only its second flight, showcasing significant progress. These key milestones set the stage for both stages of the rocket to land with the Megazilla arm early next year. Perfecting this landing technique is vital for the lunar landing capabilities of Starship HLS. Furthermore, successful landing with Megazilla will facilitate rapid, repeated launches, an essential component for the ongoing deployment of Starship HLS and Starship tankers for future missions. While most major developments are slated for next year, one particularly noteworthy event is the upcoming Flight 6. Its success could serve as a critical turning point, unlocking the subsequent phases of testing and development. This flight holds the potential to propel SpaceX onto an accelerated trajectory toward the moon, making it more than just another Starship mission. It represents a pivotal moment in SpaceX's journey, reinforcing their commitment to pushing the boundaries of space exploration and solidifying their role in the Artemis program. Though challenges undoubtedly lie ahead for SpaceX and Starship, the current progress is promising. With the newly revealed design of Starship HLS's interior, we now have a clearer picture of the environment astronauts will call home on their journey. There's still much to accomplish and many updates to come, but for now, we can confidently say, "Hey Moon, we're coming." I knew it. The world watched as SpaceX successfully caught rockets with its innovative Mechazilla arm, an impressive feat that even caught China's attention. True to form, China is eager to replicate this technology. But copying isn't always easy, especially when past attempts at mimicking cutting-edge tech have often fallen short. So how exactly is China attempting to copy SpaceX's catch technology? And why can't they match SpaceX's success? On October 13th, SpaceX captured global attention with the groundbreaking success of Flight 5, a mission that showcased a bold advancement in rocket recovery technology. The highlight of this flight? Super Heavy Booster 12's unprecedented landing, safely caught by the Mechazilla chopstick arm. A maneuver that's poised to reshape the landscape of reusability in spaceflight. The success of this catch introduces a level of precision and efficiency that stands to revolutionize launch operations, enabling fast turnarounds and paving the way for significant cost reductions. With this technology now in play, ambitious targets like lunar and Martian missions are no longer distant dreams. They're firmly within reach. China, fully aware of the impact this leap could have on the space industry, has wasted no time in responding. Rather than crafting an original approach, China has taken a direct cue from SpaceX's methodology, opting to replicate the rocket catching system. Back in July, a series of images began circulating unveiling Cosmoleap's plans to develop a similar system for rocket recovery. Musk himself acknowledged the uncanny resemblance between Cosmoleap's design and SpaceX's with the simple remark, "Look familiar." Initially, China seemed hesitant to move forward aggressively with the concept, likely because even SpaceX had yet to demonstrate the viability of the system. But the success of Flight 5 has undoubtedly shifted perspectives. Within weeks of SpaceX's milestone, Cosmoleap announced on November 1st that it had secured over $14 million, or roughly 100 million yuan, to fund the development of Yueqian, a reusable rocket program that prominently features its own version of the catch system. This substantial funding round was led by a coalition of investors, including Sheneng Chengyi, Tianquan Capital, Boyan Fund, Xiangfeng Changqing, and notable investor Zhang Chao, underscoring the level of commitment to advancing China's own reusable rocket capabilities. This marks a significant leap forward for Cosmoleap, also known as Dahang Yueqian, especially considering the company was only founded in March of this year. Their goal is to develop a low-cost, highly reliable, reusable launch vehicle, an achievement currently mastered only by SpaceX. According to Cosmoleap's statement, the company has already made several technical breakthroughs. These include constructing a chopstick clip recovery tower verification platform, developing an onboard flight control computer called Firestone No. 1, and creating the first domestic recovery tower controller, Little Firestone. This latest round of financing will go toward testing the chopstick clip tower and advancing the Yueqian launch vehicle. Cosmoleap recently shared a video showcasing their system, which bears a strong resemblance to SpaceX's Starship technology. The video also revealed the company's ambition to build its launch tower on an offshore platform. Cosmoleap is targeting a test flight for its UH or LEAP rocket around 2025 or 2026, with plans outlined by a company representative at the International Astronautical Congress in October of 2024. In the video, striking similarities to SpaceX's systems are clear. The tower structure appears to be built from steel bars, likely divided into modules like SpaceX's launch tower. The chopstick arm closely resembles Starship's Mechazilla arm. The UH launch vehicle itself mirrors the design of SpaceX's Falcon 9, featuring a 75-meter height and a 4-meter diameter, slightly larger than the Falcon 9. These specifications reveal additional likeness. UH uses a grid-fin navigation system, an octagonal configuration of 9 engines, and a methane-based fuel system, all hallmarks of SpaceX designs. Capable of lifting 10.45 tons to a 1,000-kilometer orbit in expendable mode or 6.28 tons in reusable mode, UH closely matches Falcon 9's capabilities. Like Starship, it is designed to land on the tower without landing legs. Future plans include a 126-meter version of the rocket expected to launch by 2030 with a capacity of 100 tons to orbit in expendable mode and 36 tons if reusable. These are indeed ambitious plans that Cosmoleap has set in motion. However, this path of development may lack long-term viability. While they've managed to replicate the appearance of SpaceX's designs, the core technology is far harder to duplicate. If it were simple, we'd likely see many SpaceX equivalents globally, but as of now, SpaceX remains singular, driven by Elon Musk's relentless vision. With such unsustainable progress, I predict Cosmoleap may face early setbacks. If their technological infrastructure can't match their ambitious design, investors might soon lose confidence, leading to an eventual collapse of the project. If you agree with this outlook, comment "Great script, Kevin" to let us know. And if you'd like, paint your own scenario for Cosmoleap's future. Don't forget to like, share the video, and subscribe to stay updated on SpaceX's exciting journey forward. My views stem from a history of Chinese companies attempting to emulate SpaceX's approach, only to encounter repeated setbacks. Beyond Cosmoleap, other Chinese companies like Landspace, Galactic Energy, Space Pioneer, Deep Blue Aerospace, and CAS Space have all drawn heavily from SpaceX's methods and aesthetics. However, few have found sustainable success. Landspace stands as a rare success with its Yuchui-3, marking the first methane-powered rocket to reach orbit. Yet, as more companies aim to replicate SpaceX's innovations, failure remains a common outcome. A recent high-profile example is Deep Blue Aerospace's unsuccessful test of the Nebula 1 rocket in September. Although the rocket launched, it encountered engine issues during landing, resulting in a hard collision with the pad and severe damage to its aft section. Deep Blue Aerospace had intended to produce reusable rockets akin to SpaceX to drive down costs and improve operational efficiency. But the recent failure dealt a blow to that vision, and they appear to be pivoting. Their latest update indicates a shift toward launching a suborbital capsule, a model seemingly influenced by SpaceX's Dragon and Blue Origin's New Shepard. However, given the recent setbacks, this endeavor may face the same challenges. Space Pioneer has also faced setbacks, with a striking example being the failed test of its Tianlong-3 rocket. During a static fire test, the rocket unexpectedly lifted off from the launch pad before crashing and exploding about 1.5 kilometers away. Thankfully, there were no reported injuries. The Tianlong-3 bears a strong resemblance to SpaceX's Falcon 9, with 9 engines in the booster powered by liquid oxygen and kerosene. Its specs include a height of 71 meters, a diameter of 3.8 meters, and a thrust of 770 tons. It features 2 stages, landing legs and grid fins, clear markers of SpaceX's influence. However, without a deep grasp of the underlying technology, these similarities led to failure, disrupting Space Pioneer's subsequent plans. Likewise, iSpace encountered trouble with its Hyperbola 1 rocket in July, leading to an in-flight loss of its payload. These recurring failures underscore that imitation alone cannot drive progress. For now, SpaceX remains unmatched due to its technological depth and innovative lead. But despite setbacks, it seems China's private space sector hasn't abandoned its strategy of emulating SpaceX and may even be ramping up its efforts. For instance, while Cosmoleap envisions an offshore rocket-catching tower, U.S Space is pursuing international ambitions with its Kinetica rockets. Since 2022, the Kinetica 1 has completed multiple successful launches, and the company now aims to debut the Kinetica 2 in September next year, planning 5 to 8 launches per year. Each mission could deliver up to 12 tons to low Earth orbit and 7.8 tons to sun-synchronous orbit. By late 2026, U.S Space hopes to make Kinetica reusable for Tiangong supply runs and introduce a suborbital launch system in 2027. Liu Weipeng, a manager at U.S Space, has emphasized the company's vision of establishing a robust and competitive launch market in China by attracting international clients. Although this will undoubtedly be challenging, he views it as a key opportunity, especially given the many potential partners they claim to have found globally. Their next planned launches could even carry payloads from various countries. However, competing with SpaceX, a company with a proven record of reliability and efficiency, will be exceptionally challenging for U.S Space. SpaceX's Falcon rockets and soon Starship continue to dominate the international launch market, earning the trust of NASA, the U.S. government, and a multitude of private and foreign organizations, including Europe, Japan, and South Korea. With ongoing technical and financial hurdles, it remains to be seen whether U.S Space's ambitions will materialize or falter. SpaceX's strides in reusable technology are transforming the landscape of the global space race. Each successful mission forces other space agencies and companies to rethink their strategies, speeding up timelines and pushing for innovations. China's response with Cosmoleap alongside other private ventures underscores how seriously they're taking the challenge. But while imitation is flattering, it also reveals how far behind the rest of the world still is. As long as SpaceX continues to lead in both reliability and frequency of launches, it remains the standard to beat, whether for lunar missions or Mars colonization. Stay tuned to see what the future holds for this ambitious venture. Oh dear. With Artemis 3 less than 2 years away, many questions are still swirling around this historic mission. One of the most pressing questions is where it will launch and land. Many speculate that Starship will take off from Florida, but the exact timing remains unclear. Interestingly, NASA has recently shared plans that may offer some answers. Moreover, potential landing sites at the moon's south pole have just been unveiled. Firstly, let's explore the prospect of Starship launching from Florida. Currently, Starship's operations center is in Boca Chica, Texas, where it has evolved into one of the world's premier rocket manufacturing, testing, and launching facilities. Over the past year and a half, Starship has successfully completed 5 integrated test flights, showcasing its ability to perform controlled landings of both rocket stages and facilitating the capture of the vehicle using a launch tower. This impressive track record paves the way for a historic milestone, the recovery of both stages during an upcoming launch next year, a crucial step toward the long-term goal of colonizing Mars. However, it's essential to note that Starship's mission scope extends beyond Martian aspirations. It's also integral to NASA's Artemis moon program. For this initiative, Starship will need to launch not only from Texas, but also from Florida under NASA's direct supervision. To prepare for this, a Starship launch system is being constructed at Launch Complex 39A, or LC-39A, which plans to facilitate up to 44 missions per year. Considering these developments, when might we see Starship operational in Florida? Recently, Kent Chojnacki, NASA's deputy manager of the Human Landing System program, indicated that NASA anticipates a launch cadence of every 2 weeks for Starship. This will begin at Boca Chica with 2 launch towers, allowing SpaceX to launch 1 Starship per week. If successful, this rhythm will transition to the LC-39A tower in Florida. Several factors influence this timeline, particularly the readiness of the launch tower and the anticipated launch frequency. It's likely that SpaceX will need to wait until at least January of next year to complete the launch system and a few additional weeks for it to become operational. Currently, the average turnaround time for launches exceeds 3 to 4 months. But for SpaceX to achieve a weekly launch schedule, they must first demonstrate successful full landings of Starship using the Megazilla system. This capability is not expected to be ready until early next year. On a positive note, if SpaceX successfully completes these tests, they'll have established the foundational processes needed for Starship operations. This accomplishment could significantly enhance launch frequency, potentially achieving weekly launches by late 2025 or early 2026. While some might view this timeline as close to the Artemis 3 mission, it's important to remember that even if SpaceX reaches a launch cadence of once a week in early 2026, there will still be several months available for additional launches, ensuring ample preparation and reliability for the official mission. The prospect of Starship launching from Florida brings exciting possibilities, with the potential for SpaceX to establish a presence in what many consider the Holy Land of aerospace. As the timeline progresses, Chojnacki mentioned that an important design review between SpaceX and NASA is likely to occur next summer, focusing on 27 critical requirements for the Starship system. One of the most prominent items on this list will be demonstrating the fuel transfer capability, which is expected to begin early next year with the ship-to-ship propellant transfer demo, immediately following the ship's capture mission. Following this demo, SpaceX will ramp up launch operations to meet the requirements of the refueling system. Each Starship human landing system mission will likely require at least 10 tanker flights, necessitating multiple launches to establish the reliability needed for the system's operational success. If the fuel transfer demo commences in March of 2025, it should be completed in time for the summer review, after which construction of the refueling system will begin. In addition to this critical system, the design review will also encompass the crew cabin and various life support systems, which are likely being constructed within the HLS nose cone at the production site. The review process is set to begin this month, with results and recommendations expected next year. Throughout the past year, numerous tests of the lunar suit, elevator systems, and airlock designs have been conducted and will also be included in this review. Ultimately, the final step before the official mission will involve an uncrewed test flight, likely launching from the Florida pad. Given the current schedule, this timeline is feasible. Although these processes are undoubtedly challenging, NASA is optimistic that the Starship HLS will meet all deadlines. The pace of Starship production and testing has been accelerating, supported by new systems. However, a significant concern remains: whether the FAA will impose delays. This is where NASA must actively support SpaceX to keep the project on track. In summary, the plans for Starship in Florida and beyond are set, with an active and promising year ahead. If you're excited about these developments, respond to the moon in the comments down below. Don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's journey. Indeed, to the moon. Now, let's dive into NASA's latest updates on the Artemis 3 landing sites. On October 28th, NASA released a refined list of potential landing sites near the moon's south pole for the Artemis 3 mission. 9 sites have been shortlisted, and from these, the specific landing location will be chosen along the official Artemis 3 launch date. As NASA explained, these regions contain diverse geological characteristics and offer flexibility for mission availability, Sarah Noble, Artemis lunar science lead at NASA headquarters in Washington, stated. The moon's south pole is a completely different environment than where we landed during the Apollo missions. It offers access to some of the moon's oldest terrain, as well as cold, shadowed regions that may contain water and other compounds. Any of these landing regions will enable us to do amazing science and make new discoveries. The agency added, to select these landing regions, a multidisciplinary team of scientists and engineers analyzed the lunar South Pole region using data from NASA's Lunar Reconnaissance Orbiter and a vast body of lunar science research. Factors in the selection process include science potential, launch window availability, terrain suitability, communication capabilities with Earth, and lighting conditions. Additionally, the team evaluated the combined trajectory capabilities of NASA's SLS, or Space Launch System, rocket, the Orion spacecraft, as well as Starship's HLS variant to ensure safe and accessible landing sites. In fact, in August of 2022, NASA announced a list of 13 landing locations for this mission, some of which are similar to those in this recent update. The landing sites are primarily located around the South Pole, a region of scientific and exploratory interest due to the presence of water ice. Lakeisha Hawkins, Assistant Deputy Associate Administrator in NASA's Moon to Mars Program Office, emphasized the mission's significance. Artemis will return humanity to the moon and visit unexplored areas. NASA's selection of these regions shows our commitment to landing crew safely near the lunar South Pole, where they will help uncover new scientific discoveries and learn to live on the lunar surface. As Hawkins points out, selecting a landing site reflects NASA and SpaceX's strong commitment to returning humans to the moon within the current timeline. The lunar South Pole is also highly sought after by other nations. China, for instance, has announced plans to land humans in this region by 2030, with the goal of establishing a lunar base over the following 5 years. For the U.S., reaching these locations as planned will be crucial in staying ahead and setting the stage for continued lunar exploration. To achieve these ambitious goals, SpaceX must first accomplish a series of critical milestones. The immediate priority is the upcoming Flight 6, anticipated to take place later this year, possibly within the next month. The objectives of this mission are to catch the Super Heavy booster using the chopstick mechanism and to land the Starship upper stage with controlled vertical descent, key steps improving the reliability of these innovative recovery methods. Building on the success of Flight 6, SpaceX will push toward new targets in 2025, including an attempt to catch Starship with the launch tower's arms. This test, projected for January or February, is intended to prepare the system for a crucial propellant transfer demonstration in March. The challenges are significant, particularly for Starship, as it must withstand the intense re-entry process before being caught. However, with the achievements of Flights 5 and 6, SpaceX is well positioned to make Starship fully reusable, setting the stage for the next era of space exploration and technological advancement. This is the path Starship will take on its journey to the moon in the coming 2 years. The departure point and destination have been gradually unveiled, and the roadmap between them is taking shape. Now, we watch as SpaceX meticulously assembles each step, paving the way to reconnect humanity with the moon after more than half a century. Flight 5 has indeed opened up many possibilities, fueling the dream of a future where SpaceX rockets, especially Starship, launch with increasing frequency. But the FAA remains a hurdle. Remember the recent tensions in California, where another agency prevented SpaceX from boosting Falcon 9's launch frequency along the coast. Faced with such barriers, efforts to expedite the FAA process are continually being pursued. Recently, amid SpaceX's active preparations, yet another congressman has pushed for progress. So what role will these efforts play for Starship and SpaceX as a whole? On October 28th, during a Senate Appropriations, Commerce, Justice, Science, and Related Agencies Subcommittee hearing, U.S. Senator Jerry Moran urged the FAA to expedite its rocket launch approval process, specifically calling out SpaceX's Starship program. He pointed out that the FAA's current oversight is not just a bureaucratic hurdle, but a significant barrier affecting launch schedules and vital national objectives, including NASA's Artemis program, which relies heavily on timely launches. Just a few days earlier, on October 25th, Senator Moran sent a letter to FAA Administrator Mike Whitaker advocating for the agency to rapidly improve its transparency, accountability, and pace of execution when it comes to granting launch permissions. In his letter, Moran stressed that the FAA's slow pace is detrimental not only to national security but also to the lunar program, two critical areas where SpaceX is a key player. In a show of gratitude, Musk acknowledged Moran's efforts with a simple yet impactful response. Much appreciated. Moran's push for more efficient FAA processes aligns with similar concerns raised by Texas Congressman Keith Self, who recently urged the FAA to approve a proposal for 25 launches at Starbase, Texas. This growing sentiment reflects widespread frustration within the aerospace industry regarding the FAA's persistent delays. Alongside Self, a coalition of influential voices, including California Congressman Kevin Kiley, other congressional leaders, private aerospace executives, and high-profile figures such as Musk and even presidential candidate Donald Trump, have publicly criticized the FAA's launch approval processes. Their collective calls for reform highlight a critical moment in the aerospace sector where timely approvals are essential for maintaining the U.S.'s competitive edge in space exploration. This agency is indeed the primary obstacle preventing many rocket missions, with SpaceX often bearing the brunt of these delays. Some argue that this is partly due to the political affiliations of the company's founder, Musk, who supports Trump. Personally, I believe politics should not interfere with aerospace. For SpaceX and its Starship program, without the aforementioned support, Flight 5 could have faced delays extending into late November. Even after it launched, the timing was significantly later than the company's expectations, resulting in increased intervals between flights. However, this should not happen again with Flight 6, as Flight 5 was a substantial success that did not compromise public safety. Yet, as SpaceX ramps up preparations for Flight 6 since late October, the FAA's silence is raising concerns. Similarly, with the Falcon rocket, the FAA seems to intervene whenever issues arise. The 3 delays in July, August, and September all impacted the progress of Falcon 9 and Falcon Heavy, despite those incidents not affecting the overall flight targets. The FAA issues are not limited to SpaceX. They can also impact other companies. For instance, Blue Origin's license for New Glenn is in doubt for November. However, given their close relationship, it's possible that Blue Origin's licensing will be resolved soon. In contrast, we rarely hear complaints from ULA regarding the review process, suggesting that SpaceX experiences the most significant delays due to FAA actions. From the FAA's perspective, officials often cite a lack of human resources as a primary reason for delays, especially as the workload increases with more rocket launches, mainly from SpaceX. This excuse seems inadequate. If they were aware of the issue, they should have taken steps to address it sooner rather than using it as a reason for delays. The more excuses they make, the more they reveal their lack of foresight. Meanwhile, the U.S. is at a critical stage that demands high launch frequencies. The current pace of the FAA is certainly not suitable for such a future. Given the success of Flight 5 and the backing from the Senator, we can hope that SpaceX operations, particularly Flight 6 and future Starship flights, will occur more frequently. If you support this, please respond with "Move On" in the comment section down below. Then, like, share, and subscribe to our channel to keep up with SpaceX's development journey. Of course, the change will be challenging because the FAA has many supporting agencies behind it. Agencies such as TSEC, EPA, SAVE-RGV, and FWS have been mentioned quite frequently. Recently, on the other side of the U.S., in California, SpaceX faced trouble with the California Coastal Commission, or CCC. SpaceX accused the CCC of relying on political and environmental issues to prevent the company from increasing the number of launches on the West Coast. Currently, SpaceX operates a Falcon 9 launch pad there, SLC-4E, and they are planning to take over SLC-6 to boost the launch rate. In the near future, SpaceX aims to increase the launch frequency on this coast to 50 per year. It's important to note that the launches from California are not only for Starlink but also for many national security missions because it is located at Vandenberg Space Force Base. In its documents, SpaceX emphasized that the CCC's actions violate the U.S. Constitution and infringe on the country's interests. SpaceX stated, rarely has a government agency made so clear that it was exceeding its authorized mandate to punish a company for the political views and statements of its largest shareholder and CEO. Additionally, SpaceX specified that the company's activities have no significant effects on coastal resources either on or around the base. However, this controversy is unlikely to resolve quickly, at least not until after the presidential election. The CCC is perceived to be deliberately stalling SpaceX's efforts because Musk supports Trump, the leader of the opposition to the Democratic Party, and California is a state that generally supports this party. In my view, everyone has their own political opinions, but we should not allow them to interfere with common goals, in this case, aerospace activities. We all want the U.S. to maintain its leadership in every race despite challenges from other countries. Unfortunately, some agencies seem to undermine that mission. The CCC's actions will certainly have a direct impact on the state of California. Musk has previously relocated his home from California to Texas, along with the headquarters of Tesla, X, and SpaceX. This shift could significantly affect the state's economy, as these are all major companies providing numerous jobs. Moreover, the CCC's interference may be affecting the support efforts of some individuals, such as Congressman Kevin Kiley, as mentioned earlier. In fact, the CCC's actions may not even have the backing of the California government, but just such an obstacle is enough to create substantial difficulties. We're in 2024, and a critical period lies ahead, presenting a significant choice for the FAA and the agencies behind it. Let's examine the two aspects that Senator Jerry Moran mentioned: national security launches and the moon race. Regarding national security launches, the U.S. Space Force is operating the National Security Space Launch Program, which includes SpaceX. SpaceX's role is expanding as other contractors like ULA and Blue Origin struggle with delays. ULA and SpaceX are currently in Phase 2 of the contract, and SpaceX will need to ramp up the number of launches in the coming years to meet the USSF's requirements. Following this phase, SpaceX will join ULA and Blue Origin in Phase 3 from 2026 to 2029, where the number of required launches will be high. It's important to note that SpaceX also handles many secret missions for the Pentagon, such as last year's X-37B launch on Falcon Heavy. In terms of the moon race, competition is intensifying, with numerous players entering the field, especially China. In response, NASA is developing an Artemis roadmap in which SpaceX, with Starship's Human Landing System variant, will play a crucial role in returning people to the moon by 2026, followed by the construction of a lunar base. To prepare for these critical missions, SpaceX will need to conduct numerous launches to ensure reliability. While our country's plans currently outpace those of its competitors, even a slight delay could alter the situation significantly. As mentioned earlier, the current pace of the FAA and the obstructions from environmental agencies are unsuitable for such an ambitious future. At this juncture, I believe there are two options for them: reform or be removed. This decision needs to be made swiftly. The upcoming period will not provide us a second chance to rectify mistakes. The forthcoming presidential election may clarify the path being chosen. Which do you believe would be the better choice for the FAA and some government agencies? Reform or removal? Skipping this, for aerospace enthusiasts like you and I, we can only hope to see SpaceX create more miracles in the future. Falcon has set many records this year, and what we are waiting for in the remainder of the year is whether it can achieve the target of 148 launches, which is essential for this rocket system to operate more effectively in the coming years. As for Starship, we anticipate Flight 6 will conclude a booming year and lead us toward full reusability and beyond. Hopefully on that path, there will be no barriers to overcome. The success of Starship Flight 5 is not only a technological pinnacle, but also opens a promising future for the aerospace industry and human space exploration. But wait, not everyone is excited about that. A prime example is the European aerospace sector, which has fallen behind in recent years due to the superior power of SpaceX's rockets. With the success of Flight 5, Europe's dream of competing with SpaceX is becoming increasingly distant, raising concerns about a bleak future ahead. So how did Europe react after Starship Flight 5? Catching the Super Heavy booster with the Mechazilla arm and landing the Starship vertically in one flight is an unprecedented feat in history. This achievement serves as a stepping stone toward full reusability, a crucial factor for deep space exploration such as returning to the Moon, Mars, and beyond. NASA, more than anyone, is the happiest with this success, as Starship will play a vital role in the Artemis program. However, across the Atlantic, a different mood is emerging in European aerospace agencies and companies. Recently, Rocket Factory Augsburg, or RFA, prominent European space company, posted, "Congratulations to SpaceX. What an incredible feat of engineering. Mars, here we come." At the same time, the coin has a second side. It shows and confirms that Europe has completely lost touch. Can it still catch up? No chance, at least not with the way things are going at the moment. They later added, "Europe has ambitious private space players, with innovative ideas, courage, and a vision. Unfortunately, they are being held by the long arm and are in danger of withering away while old structures, processes, and mindsets are maintained. What we need immediately and scientifically are state anchor customers, substantial investment, and a framework that allows and promotes unbureaucratic, fast, and risk-taking development. Otherwise, Europe will quickly sink into insignificance when it comes to the exploration of space, its resources, and its potential. And we leave it to the rest of the world to make history. Just like SpaceX did yesterday, it is up to Europe, up to us. At the International Astronautical Congress 2024, ESA Director General Joseph Aschbacher expressed admiration for Starship Flight 5, but he also raised concerns. What does it mean for Europe? What will be the change in the landscape and the ecosystem, and what do we need to do? He admitted it would be difficult for Europe to compete with Starship, but suggested Europe could benefit from the industry changes Starship brings. He goes on to say, if Starship brings 100 tons into space frequently, this would change everything, how things are constructed and how space is utilized. He also supported RFA's perspective and emphasized that Europe is on the right track but must move full speed ahead. These reactions show that European aerospace agencies and companies recognize SpaceX's superiority. Ambitions to beat Elon Musk's company may have ended before they even started. This isn't just a European issue. When comparing any organization to SpaceX, it's clear there is no chance of surpassing them. SpaceX is demonstrating absolute dominance over any organization in history. Unbeatable might be the most fitting word to describe SpaceX right now. You can comment that word below to spread it further to SpaceX's competitors. Then, like, share, and subscribe to our channel to keep up with SpaceX's journey. Meanwhile, in Europe, a complex mix of factors has contributed to the region's current challenges in the aerospace industry. These range from technological setbacks to organizational inefficiencies, and together significantly slowed progress, leaving Europe struggling to keep pace with SpaceX's rapid advancements. Let's start with their rocket for the future, Ariane 6. Developed by ESA and Ariane Group, it was expected to replace Ariane 5 and maintain Europe's autonomy in space launches. However, this rocket has been delayed for many years. Last year, ESA admitted that they had lost the ability to send payloads into orbit. This directly caused Europe to lose its autonomy in space missions. After no longer being able to rely on Russia, Europe had to seek help from SpaceX, the company it once considered a rival and aimed to surpass. After this long period of delay, Europe has finally made some progress with the debut mission of Ariane 6 this year. Although it was declared a success, the flight encountered several issues during the final phase. Therefore, it'll require significant further effort before this rocket can be put into stable operation. In addition to Ariane 6, Europe also has the Vega rocket family. However, following the failure of the Vega C version in late 2022, the launch frequency of this rocket line has decreased even further. Combined with the delays of Ariane 6, the Vega program has contributed to Europe facing a launch crisis. The weaknesses of these rockets have caused Europe to lose many valuable launches to SpaceX or to pay high fees for SpaceX rocket launches. A notable example is the Galileo satellite. Previously launched by Soyuz and Ariane 5, Europe had to pay more than 30% above the normal launch price at around $196 million for 2 Falcon 9 flights to launch these satellite constellation missions. As we know, with SpaceX's support, both missions were successful. Another prominent ESA mission launched by Falcon 9 is Hera. This spacecraft also changed launch vehicles like Galileo, and similarly, this mission was successful. In fact, it was considered a return-to-flight mission for Falcon 9 after delays caused by Crew 9 issues. After the first Ariane 6 mission, there were positive expectations, but it now seems like ESA is still struggling to launch subsequent missions with either rocket. Even if they manage to launch successfully, it'll be difficult to compete with SpaceX's rockets. Looking at the commercial launch market, Europe's future doesn't appear promising either. For instance, RFA, the company that congratulated SpaceX as mentioned earlier, faced a significant setback on August 19th. During a booster test for the RFA-1 rocket, there was a major explosion, resulting in the complete destruction of the prototype and severe damage to the test stand. This failure highlighted the technological challenges faced by the company, which has always tried to learn from SpaceX. But success isn't easy. Many companies worldwide, notably in China, have tried to emulate SpaceX, yet most have failed. For RFA, this failure has impacted many of its immediate plans. More importantly, the future of European aerospace appears bleaker than ever. At the same time, SpaceX continues to rapidly expand and strengthen its orbital fleet, showcasing its unmatched capabilities. SpaceX, with its 3 orbital rockets Falcon 9, Falcon Heavy, and Starship, has now surpassed 100 launches for the year, showcasing unquestionable dominance. Falcon 9 surpassed last year's record of 91 launches in late September and is now on track to reach 100 launches, perhaps as soon as this week. Afterward, it is expected to achieve up to 148 launches in the remaining 2 months, although this goal may be harder to meet after having a few delays in the past. Falcon 9's sibling, Falcon Heavy, continues to maintain its reliability. While it doesn't launch as frequently, each mission is impressive. It has launched 11 times so far, with every mission a success. The most recent was NASA's Europa Clipper mission, further adding to Falcon Heavy's impressive track record. With these 2 rockets, SpaceX has dominated the industry, making Europe dependent on its services for many years. Now that dependence is likely to grow as Starship, the vehicle mentioned earlier by ESA executives, achieves rapid and impressive progress. In just over a year, SpaceX has mastered the process of reaching orbit, landing the booster with the Mechazilla arm, and is aiming for even more ambitious goals. The launch rate will continue to rise following the success of Flight 5, and remember, Starship's capabilities, such as its large payload capacity and full reusability, make it highly competitive. This has led to its selection for many critical missions, including Artemis and Mars colonization efforts. It wouldn't be surprising if Europe comes to rely on Starship even more than on Falcon rockets. The common factor across SpaceX's orbital fleet is reusability, both partial and full. This key advantage sets SpaceX apart from the rest, including Europe. Once again, SpaceX's superiority in the industry is unmistakable, setting a new standard that others struggle to meet. Its relentless innovation and unmatched launch cadence have solidified its dominance in the aerospace industry, leaving competitors far behind. For years, the company has successfully utilized its Falcon rockets to achieve a remarkable level of efficiency and reliability in reaching orbit, setting new standards in the sector. With the introduction of Starship, SpaceX's leading position is set to become even more pronounced. This next-generation spacecraft, boasting impressive performance metrics and ambitious designs, is expected to revolutionize space travel, enhancing payload capacity and mission versatility. Starship will not only reinforce SpaceX's advantages, but also usher in a new era of space exploration. Despite SpaceX's significant lead, strong competition is still anticipated in the industry. Surpassing SpaceX may seem daunting, but the spirit of innovation and competition is crucial for advancing space exploration. Organizations worldwide, including those in Europe, are making strides in their own programs, striving to maintain a competitive edge and open new pathways for humanity's understanding of the universe. Under SpaceX's leadership, space exploration is becoming more accessible than ever, paving the way for scientific endeavors, commercial opportunities, and international collaborations. The future is bright, full of possibilities, and we are on an exciting journey into the cosmos. With each launch and milestone achieved, we draw closer to fulfilling humanity's long-held dreams of exploration. And that just about wraps it up for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.